Hello, Faiz. So I am in the Toronto airport going to Vancouver right now. And now I'm in Vancouver. Okay, so filming the airport is slightly awkward, and people are giving me funny looks. So anyways, I'm sure you've noticed this on your flight to China. When you're looking at the destination map on your plane always seems to be traveling in a curve rather than a straight line. Since the fastest path from one point to another is a straight line, why would a plane decide to take a detour by going in a curved path when it could be much more efficient with a straight path? Well, aside from ground control telling the plane to avoid certain areas, the curved path you see on the map is actually the fastest path. And here's why. So our planet is pretty much a spherical object, and the shortest path between one point and another on a sphere is a straight line that goes across. So let's say you want to travel from Vancouver to Beijing. We're just going to mark this path with a straight line across the globe. Like so. That is my earphone because of lack of funding. If I turn the globe like this, you see that this straight line actually looks curved. This is because the map on your plane, just like your computer screen, is not a three-dimensional sphere, but a two-dimensional plane. If you want to project a two-dimensional line from the surface of a sphere onto a plane, that line will appear curved on the plane. Okay, so that is satisfactory. But what about the shape of a continent? What will happen if you project the entire globe onto a two-dimensional map? Well, obviously with the existence of our maps, such projection is possible. However, it is impossible to keep the distances, areas, and shapes of the figures from the sphere onto the plane. This is actually proven by the mathematician Gauss, who among all his discoveries gave us the Gaussian curve, or the bell curve. Yes, bell curve. What this means for our maps is that the world map as we know it is inaccurate. You might have seen the actual gigantic size of Africa in this image with all the countries fitted inside. According to the famous Mercator map, Africa is tiny. So from this image, with circles drawing on the Earth's latitudes, you see that the common map distorts all the continents by making everything near the poles super big and everything at the equator super small. The main reason why the Mercator map is so popular is because it maintains shape very well. There are many different world maps out there trying to preserve one distinct feature of the world, and I have posted the link below. However, none of it can accurately give us the exact image of Earth. The best way of visualizing the Earth is using the Earth itself, which is the globe. It seems so far all I've been doing is disproving everything you know, from time to maps. Alright, so let's go back to planes. I am sure you've wondered sometime in your life, how do planes fly? The reason why a plane can take off and stay in the air is because of the shape of its wing, which will generate a force called lift as it travels through the air. And lift will counteract gravity, bringing the plane up. The cross-section of a wing looks like this. The air on the top of the wing will travel slower than the air on the bottom of the wing. This is because the bump on the top of the wing forces the air to speed up as it travels across, so it can reunite with the bottom counterpart on the other side of the wing. The movement of air creates pressure on the wings, and according to the famous Bernoulli's equation, the faster air on the top of the wing will exert a smaller pressure than the slower air on the bottom of the wing. So the higher pressure on the bottom of the wing will generate a force that will lift the plane up, and that force is lift. If the plane is traveling fast enough, the lift will be higher than gravity, pushing the plane up and into the sky. Lift and gravity are two of the major forces that can affect a plane. The other two are drag and thrust. Thrust is the force generated by the plane's engine that will allow the plane to move forward. However, because air is a fluid with a certain viscosity, there will always be a counterforce called drag. Essentially, what drag is air resistance, which counteracts thrust, just like how gravity counteracts lift. For the plane to lift off, travel around, and take off, these forces are to be manipulated and balanced in certain ways. For example, if the plane needs to go higher, we will need to increase lift. But if you want to land the plane, you will decrease lift so that gravity can drag the plane down. Now, wouldn't this knowledge have been helpful when we were building the plane project in grade 9? Alright, Faiz, I'll see you on Tuesday.